Hi, good morning and welcome to the ZP Developer Zone. So every Thursday at 8 a.m. London time, we like to do this webinar for the members of our ZP Developer Zone. So let me jump straight into it. So I always put this slide up, but I'll just go through it quickly. If you're new to biosensing, and I suppose this is very relevant, we do have the ZP Academy, and then there are 2 courses on the ZP Academy that are free. So if you're new to it and some of the terms that we use are kind of newish, please sign up for the ZP Academy. There are 2 free courses on there: Introduction to Biosensors and Techniques for Electrochemical Biosensor Developers. So please take a look at that. We do our webinar every Thursday at 8 a.m. and we also do a vlog on Sundays at 8 a.m. and these are London times. So here's the webinar today. And we have collaborations. It's probably worth saying that we do actually, looks like we're going to have 2 professors visit us this summer. And also we're getting a student coming in from Canada, and I know that we're also got a ZP Developer Zone member coming in from Turkey. I just want to say hi to Aftab. Nice to see you this morning, Aftab. We do post jobs, and we do have a dedicated website to the Developer Zone. So I'm sort of speaking rather fast because we do have a lot of material, and we also have workshops. Just as an FYI, what we do online workshops as well as in-person workshops. So we do have a workshop in Spain in May, and we are with Technando, our Indian distributor. We are doing a sort of webinar / workshop next week as well. So I will sort of plow through it. Topics for discussion today are, I'll go a bit quicker. Lactate Generation 2 sensors. So we do have a lot of people interested in using our Lactate Generation 2 sensor. I suppose in this webinar I haven't defined what Generation 2 is, but they are using the Generation 2. We've had a question about detecting glucose in sweat, but when I looked into the question a bit deeper, they were also interested in lactate and cortisol, so I could comment upon that. We do have some questions sometimes about this thing called a Severinghaus electrode, and I will touch upon that. We are having a question at the moment on the fructose sensor, and I will essentially dive into that today. And then also we do get a lot of bits and bob questions about Djuli, so I'll just show you a new resource for Djuli as well. So as I say, I am speaking rather fast, but that's sort of 5 things to get through. And we do like to be efficient with your time. You know, we like to do this in a sort of 30 minutes. Now, this is a list of questions. So at Zimmer & Peacock, we make, lactate sensor, glucose sensors, potassium sensors, sodium sensors. But the questioner here has a Generation 2 lactate sensor. And the first question is how do I store my my lactate sensor? Store in the fridge at 4 degrees C. Because by putting it in the fridge, you're keeping it cold, so that's a good start. The fridge is actually quite a dry place. There's actually quite low humidity in the fridge, and it also keeps it dark. So store in the fridge at 4 degrees C sounds like, or feels like good advice. So that's how we store these lactate sensors. I think the questioner was also maybe asking a bit about functionalization. How do we do the functionalization? So I will have a slide on how we do the functionalization, and I'll talk about how we use 3 micro drops to do this. I think they're actually more interested in how we test it. So I'll describe Beaker testing, which I think they're completely familiar with, but I'll also talk about drop testing. There's something to say about Zimmer & Peacock that our electrodes, whether they're screen printed electrodes or whether they're electrodes that have been functionalized into biosensors, they're designed to allow you to use basically a drop of blood, etc., on them. So a drop of blood, and that drop of blood is my drop of blood. So I've just sort of demonstrated. I prick my finger and put a drop of blood on there. I just want to demonstrate to you that the reason our sensors look like they look is because actually, you can use a drop of blood, for example, on them, and that's enough sample to test with them. The other question was about reusing sensors. So we do reuse the sensors. We can't say how many times you can reuse a sensor because I don't always know what solutions you're putting onto them. The question, can I reuse something? The quick answer is yes. The longer answer is yes, but you know, how are you using it? How long are you using it for? These are very nuanced questions. When we're reusing sensors, we rinse the sensor after use. So we'll often rinse it with deionized water, and then we dry the sensor. And when we dry the sensor, we take some lab tissue and we tear it, and we just wick off the solution very gently using the lab tissue. So if you want to reuse the sensors, you have to be able to store them. We don't want to store them, for example, if it's a lactate sensor, I don't want to store it with lactic acid on it. So we wick it off with some tissue, and we also rinse it, and then we dry it as well with some tissue, because we don't want to store it wet. So those were a list of questions. I'm going to dig into some of the questions a bit more deeply now. In terms of functionalization, you know, how we often functionalize electrodes at Zimmer Peacock. I know it's very boring, but what you're going to notice is that all the electrodes that we use, they all look the same. And this is not that webinar, but we do talk about this in a webinar that, you know, at Zimmer Peacock, we can achieve fairly high quality at low cost, because actually we're not trying to make a fragmented set of electrodes. They all look very similar. So you can see that we actually have a core platform upon which we're building. Anyway, the question is about functionalization. So we take one of our electrodes, we put 3 micro drops along it. We do this with a robot, but our guys can also do this in the lab by hand pipetting. They're really, let's say, skilled, and thanks to them for that. And then we can, those 3 drops will coalesce, and we'll have a sort of coverage like that. In fact, I don't have it today, but we do have a new blog article about how to measure that coverage, but I don't have it as part of that webinar today. So that's how we functionalize. So if you have a lactate sensor off us, or a glucose sensor, or a cortisol sensor, this is how we would have functionalized it. Now, I think what the questioner was actually asking, they have a generation 2 lactate sensor. We do a lot of what we call drop testing. And, you know, we'll take the sensor, we'll put the sample of interest onto it, and that sample is, I've put the perimeter around here so that you can see that what we're trying to do is we're trying to make sure that the working electrode is covered, we're trying to make sure that the reference electrode is covered, and we're trying to make sure that the counter electrode is covered. So you can see that it's just a corner of the counter not covered there, and just a corner of the reference there, but that working electrode is definitely covered, and everything else is fairly well covered. And that generally takes about 30 microliters drop in order to do that. It's probably worth saying that when we create microfluidic chambers, we can get that sample volume right down. You know, 4 microliters. A lot of glucose strips on the market are 300 nanoliters. So, but when it's bare like that, 30 microliters is super sufficient. And you know, we just often add it just with a sort of little dropping pipette like that. So not very hard. So we do, when we test our generation 2 lactate sensors, quick testing can be done just by dropping sample on and off. It's really, you know, not that hard. You just got to make sure you don't get the liquid up into the electrical connections. That's an absolute disaster. But I think many of you listen to this webinar have a, you know, electronics background, and I think everyone knows, you know, don't mix, unfortunately, electricity and water and liquids. We often test by Beaker testing. This is Andre. In this example, he's using the Sense It Smart, and he's got one of our glucose sensors stuck into it. And we often test by in a beaker. Now we will also often put a magnetic stirrer under there. Magnetic stirrers can cause you electrical noise, which can interfere with your signal and give you sort of high frequency noise on top of your signal. If that's the case, just turn the sensor off. Sorry, not turn the sensor off. Turn the magnetic stirrer off when you actually want to make a measurement. The reason we stir is because we're often adding extra sugar or extra glucose, for example, and we want it to rapidly dissolve, or not dissolve, we want to rapidly disperse it into the sample. So we often do beaker testing. We often have a magnetic stirrer. Be careful of magnetic stirrers, they can introduce electrical noise. But the questioner was asking, how do we test? And the answer is we test by drop testing. We also test by putting into beakers. And yeah, the signal will actually look different in both cases, because the volume and the mass transport in those two types of scenarios is actually different as well. Detecting glucose in sweat. We've been asked, do we have technologies for detecting glucose in sweat? And the answer is we do. We obviously have glucose sensors. This is one of our generation 1 glucose sensors. If I was going to start in the world of biosensing, and it was my first foray into glucose sensing, I'd probably start with what I call our generation 1 glucose sensor, just because it's the lowest cost. It's also very robust. The nice thing about glucose sensors as opposed to lactate sensors, and Aftab, who's online this morning, knows this. I've said it ad nauseum, that the glucose sensors are so robust relative to the lactate sensors. Now we also have these kits which allow you to adhere these sensors onto the skin. It's probably worth saying that these kits are really for doing proof of principle. They're not robust enough to be the final product. It's probably worth saying that we did a webinar last week where we actually talked about the cost to get medical products to the market in the USA, and I was showing costs like $74 million to get things to market in the US, to get regulatory approval in the USA. So we do have these kits and these starter kits, but beware, that's a big gap between that and you receiving regulatory approval. But we do have these glucose sensors. We do have these patches. We do have a nice video. I'm going to put a link in a minute. The link is already underneath this sort of YouTube webinar, but we do have a video on the same page that we have the kits, and it shows you how we assemble these things as well. So it's probably worth a look. So there's a link to a glucose sensor and there's a link to a sweat patch sensor. So if you want to monitor glucose in sweat, you're taking on one of the toughest challenges, I would say. But I think it's if you can pull it off, you're doing really something quite amazing. And I think all the type 1, type 2 diabetics around the world will really appreciate it. We do have essentially starting technology, which is the glucose sensor and the patch. This link here, sweat sensor, sweat patch. We do have a video there how to assemble these sweat patches, let's say. The inquirer is also interested in lactate and cortisol. So we do have a lactate sensor, and we have something very rare. We actually have a cortisol sensor as well. I just want to say hi to R2A. Thanks, Martin, and good morning. Yeah, thank you, because I knew that your inquiries are mixed up. Hopefully I'm going to cover your inquiry as well in this webinar. If I don't, remind me and we will go back over it. But the questioner was asking, can I do glucose in sweat? Yes, you can. There's a glucose sensor, there's a sweat patch. Can I do lactate? Yes, you can. And can I do cortisol? Now, the biggest challenge with monitoring something in sweat is the clinical proof of this. Is there a correlation between, for example, in the case of glucose, is there a correlation between glucose in the sweat and glucose in the blood? And that's a clinical question, and I might have opinions on it, but I do not have the evidence for it. That takes a clinical trial. And I suppose it comes back to my point earlier on. We definitely, in last week's live streaming webinar, we did talk about the cost of getting these kind of technologies to market. And I know I already said it, but 74 million did appear in that. So be careful. Biosensing is a long and expensive route. The technology that we have on our website is an accelerator to get you sort of proof of principle. It's probably worth saying that ZP, most of our effort is actually contract development, contract manufacturing to people who genuinely want to get to market, and these are not low cost endeavors. So here's some useful links. That's one to the lactate sensor. This one's to the cortisol sensor. I think the cortisol sensor from ZP is actually unique. I don't believe they exist. I know I'm slightly changing gears now, but we had something like 5 questions. I've done 2 of them. It's 1/4 the hour approximately. So I'm going to go into what's called a Severinghaus electrode. So a Severinghaus electrode, I believe, is traditionally been used for measuring carbon dioxide in the blood. So there's these clinical analyzers, they're called blood gas analyzers, and they'll do a series of tests. pH will be there, lactate will be there, glucose will be there. They'll call it PO2, but dissolved oxygen will be there, sodium will be there, potassium will be there. I want to say creatinine will be there, maybe cholesterol, but there's blood gas analyzers. And anyway, they also have something called PCO2, which is like the partial pressure carbon dioxide. What's the dissolved carbon dioxide in the blood? And they'll use something called the Severinghaus electrode. This electrode looks like a traditional pH electrode. It works really on, I would say, the same principles as a pH electrode. If I do a schematic of it, it looks like this. You have a sort of a barrel with a pH electrode or pH sensitive electrode in it and a reference electrode in it. In the barrel of the electrode, you'll have some solution. We'll discuss that in a minute. And at the end of this barrel, you'll have a membrane, a gas permeable membrane. And so CO2 in the liquid sample, for example, will diffuse through that membrane. So we have a polymer and also a spacer. So the CO2 gets through, and when it gets through, it's essentially dissolving with the reacting with the water to give you sort of carbonic acid, and carbonic acid dissociates to give you protons. So what we're doing is we're actually measuring the protons at the pH sensitive electrode, and we're measuring the voltage difference between the reference and the pH sensitive electrode. So it's a millivolt signal out, and the millivolt signal out is proportional to pH, which is proportional to the original CO2 on the outside of the membrane. So that's what it looks like. That's the principle. And we get inquiries, do we have it? What we have is we have a pH solid state electrode. I think I made the comment at the very beginning that so far I've shown you lactate sensors, cortisol sensors, glucose sensors. They all look exactly the same. And it's because we are being successful in actually, limiting the diversity in these sensors. This is the pH sensor, and you can see it looks very similar to the other sensors that I've been discussing this morning. Now, the reason I bring it up is because to make one of these Severinghaus electrodes, it's a very 3D object. It's very constructed. It's my opinion, but I suspect these things cost at least $200 US. And now at ZP, we have these pH electrodes that I think we're selling a pack of 10 of them for $200. And that's in low volume. So we are able to, make pH sensors at a solid state. It's all done by printing, so we can really drive down the cost when we go to volume. If you want to make a Severinghaus electrode from it, then we have a pH electrode on it. We have a reference electrode on it. So in order to turn that into a Severinghaus electrode, it probably needs a perimeter around it, a sort of dam, and then over the top of that, a film. At which point then, if you have a solution underneath that film, then you've sort of made yourself a Severinghaus electrode. So what I'm saying is, we get inquiries, do we have a Severinghaus electrode? I think the answer is we have the component of it in terms of the pH electrode, but you will have to functionalize it or put some extra membranes on it to make it a true Severinghaus electrode. But I believe that is actually quite possible, and that's a link to our pH electrode there as well. So thank you for the question. It's not an easy answer, but I've given you, the sense of how we would do it, and that's a link to the pH electrodes. Question number 4 was really about fructose sensors. So change your gear again. The guy sort of says he wants a plug and play solution, and so we have the fructose sensor. It's probably worth saying that our fructose sensors are generally designed for measuring human health. If you're in the food and beverage industry, then we probably have to do a custom design, because the fructose in drinks, etc., I suspect is much higher than 20 millimolar. But we do have a fructose sensor. It works a treat. The way we probably tested this is in the Beaker configuration. And I'm showing again, Andre, he's using an Android phone, and he's got a Sensit Smart plugged in it, and he's got, in this case, a glucose sensor, but you can use the fructose sensor in the same way. So that's a bit of a closer up picture of it. These are on our websites, by the way. So the fructose sensor does exist. This has been developed really for sort of the idea of human health. If it's going to be used in the food and beverage industry, then I suspect we'll have to do a custom design, because I think the fructose is much higher than 20 millimolar. Now the list of parts you'll need for this, you'll probably need a Sense It Smart. So we do have a Sense It Smart, and it comes with a kind of cable. We do have the fructose sensor, and we also have some test solutions. It's probably worth saying that it's probably, before you start jumping into real world samples, it's a good idea to use some laboratory synthetic samples. Everything goes crazy once you start using real samples, but at least to get if you're really new to biosensing, start off with these kind of synthetic samples before you, let's say, jump right into it. I'm going to just put some useful links up. So this is the fructose calibration solution. This is the fructose sensor, and this is the link to the Sense It Smart. And as I say, they are actually underneath the video this morning, and I hope that is useful to people. Last thing is Djuli. So at Zimmer & Peacock, we do contract development, contract manufacturing of biosensors. And as part of that, we have the screen printed electrodes, we have the electronics, we have quite good application knowledge. You know, if somebody asks us a strange question, can I measure chloride in concrete, as an example, then we can probably have a fairly intelligent conversation about that. The last part of all of this is something called Djuli. So Djuli is a database that we have. It's online. If you Google essentially Djuli, you'll pretty well quickly find it. And it's something that we use for the storage of electrochemical data, the processing of electrochemical data, the visualization of electrochemical data, and data sharing. So if somebody's collaborating with us and they want to sort of essentially send us data, we'll get them to put it up into Djuli and then just share it from Djuli. Now the reason I'm bringing Djuli up as well is it does show you that at ZP we do have this kind of entire technology stack. You have a sample goes on sensor, sensor's powered by electronics connects to the web, and we can actually then send the data to the cloud as well. So it is that entire sort of sample to cloud workflow, and that is the modern way, let's say. So we have Djuli, and we do use it in programs with clients to accelerate them, and also as some of their product offerings. The reason I'm bringing it up now is we do got a lot of questions about Djuli, so we've opened up a FAQ section on Djuli. I will put a link to that in a minute, and on there I have a few videos about exporting data from Djuli, how to share data in Djuli so you can share it with people like us, how to provide feedback in Djuli. We always want to know how to improve it, and then uploading data. So one of the good things about Djuli is you can upload data from a manufacturer called Delta T, a manufacturer from CH Instruments. So many of you who are in the electrochemistry space will have heard of CH Instruments. You can upload data from Palm Sense, for example, upload data from Autolab, and do, really importantly, batch analysis of biosensor data as well. So I just want to kind of say that if you've got questions about Djuli, we do have an FAQ page about this, and I have put a link to that underneath the video below as well. So I did speak rather fast. Like I said, I apologize if I've missed some details or missed the question. We did get quite a lot this week. We will cover it. Any mistakes of missing something, pop me an email, pop me something on LinkedIn, do it on the developer zone, and we will try and answer those questions. So let me summarize. So for Lactate Generation 2 sensor, we have talked about how to store them, 4 degrees in the fridge. We have talked about how we do the functionalization. We have talked about that we do drop testing with 30 microliters, or we do beaker testing as well. And we have said that you can reuse these. You need to sort of rinse them with DI water, and you need to sort of wick off that excess DI water with a tissue gently so that you essentially dry them. You don't want to store them wet. Detecting glucose in sweat. If you can do this, you're going to really help the world. But we do have the glucose sensors. We do have the patch. If I was dipping my toe into this area, I think I would be using our glucose sensors the sweat patch that I've highlighted, and I'd also be getting that Sense It Smart as well. I think it's a low cost potentiostat and a good way of getting into this market. For those who've been inquiring about Severinghaus electrodes, we've talked about how you could basically, I think, convert our standard pH sensor into a Severinghaus electrode. Fructose sensors. I think with fructose sensors, if I was new to biosensing, it's the same thing. I'd get a fructose sensor, I'd get a Sense It Smart, and I'd get some of that synthetic test samples, and just do some lab testing. If you're generally in the food industry or the beverage industry, then I think fructose in these samples is much higher, and we'd have to do a custom design for that. And finally, Djuli. Djuli's online. You can find Djuli. There's a link underneath this video, but you can also just Google it. You'll soon find it. And we do have an FAQ page as well, which I've also linked to underneath this video. So it's now 8:26. I think I've spoken without taking a breath, without hesitation, for 26 minutes. So I hope that was useful. If you've got further questions from ZP, reach out to me and we'll sort of build upon it in some future webinars. Otherwise, I do want people to take care. I will see some of you on Sunday for our vlog. Just as information, next week in Barcelona, there's something called ATTD. It's a European large conference on diabetes, and ZP will be attending and exhibiting there. I'm not expecting you all to be there, but I just want to let you know we will be there, and we can probably report back from that as well. So thank you very much. Take care. AFTAB, I will speak to you all soon, and I look forward to doing a webinar with AFTAB next week. We're going to be doing it for a Indian university. So if you're connected with universities, let them know that we will actually do educational webinars, including live demos, and we try to help our academic colleagues that way. Otherwise, cheers AFTAB, and I shall speak to you all soon.